Welcome students in the next lecture of brief history of nanobiotechnology. In the last lecture, we have studied about the basics of nanotechnology. Here in this lecture, we will talk about how we have used nanotechnology in the past, and we will cite several examples of use of nanoscience and nanotechnology from Roman era, from old eras to new era, from in the modern time also. Then we will also discuss how nanotechnology is converted into nanobiotechnology with the addition of biotechnology, and why it is so significant for us to learn. With the end of this lecture, we will be able to gather all the information about nanotechnology and nanobiotechnology so that you can start your syllabi properly. We begin with learning outcome, then the student specific learning outcome we will discuss. In this lecture, we will start with pre-modern examples of nanotechnology, then what we have developed in the last century, then in the present century. We will take some examples from Roman era, we will take some examples from Faraday, then in the recent time, the nanotechnology started with Richard Feynman in 1959. From there, we will take examples from development of many things like STM, AFM that leads to the rapid development of such field. And we will also discuss then how biology and biotechnology worked with nanotechnology to get various solutions to develop various technologies for human welfare. We will learn about pre-modern examples of nanotechnology, then developments, present centuries developments, past century developments. Then now we have started development of products. Recent, everything is in infant stage. So we will talk about what we have developed and how it can be further increased. Then STM applications and other applications. Pre-modern examples of nanotechnology can also be cited. Early examples of these nanomaterials were based on craftsman empirical understanding and manipulation of materials. They use high heat as a common step to produce these materials with novel properties. Yes, whatever we know about this past age or the pre-modern age, that they might not have too much mathematics and too much science. They might not know these things. But even though they knew these things, they knew the understanding of manipulation of materials. They knew how the glass can change colors on heating, on addition of some other things, or to prepare these things in a different way. So if we move to pre-modern era, then we will see then many examples of nanotechnology. As you can see in this figure, these are the figures of windows used by the old era people. These colored windows, where we know now that they use gold, silver to change the colors. They knew the method of development of glass of different colors. One of the interesting example from the past is Lycurgus cup in Rome. This is an example of dichroic glass, two colors. It was assumed that this is from 4th century and made up of colloidal gold and silver. Colloidal gold and silver in the glass allowed it to look opaque green when lit from outside, but translucent red when sunshine through the inside. We have shown these images there. You can observe this green and red both dye behavior, which is due to colloidal gold and silver. This cup you can see in the British Museum, and in the next slide I am showing you a small video which is containing this cup. How interesting this is. This is one of the first example of existence of nano in the 4th century. Here you can see the cup. See this cup. This is the cup. This cup in British Museum. The glass appears from above, light sunshine outside, then inside looks like green. See. In 19th to 17th century, glowing, glittering, and lustrous ceramic glaze used in the Islamic world and later in Europe contained silver or copper or other metallic nanoparticles. In 13th to 18th centuries, Damascus saber blades contained carbon nanotubes and cementite nanowires and ultra high carbon steel formulation that gave them strength. So we can't say the NW developed recently. It has been used in Europe, in Islamic worlds from anywhere, everywhere, from 4th century, then 9th century, then 17th century. There are so many examples you can obtain from here. Here it is shown the south rose window of Notre Dame Cathedral from 1250, example from the 13th century. Here we have shown some blades. The sharp objects is contained carbon nanotubes and cementite nanowires. An ultra high carbon steel formulation that gave them strength, resilience, ability to hold a niche. The Moir fringes were observed when we took this electron microscope of these blades, and that concluded that the possibility of nanoparticles there. The Damascus suburb is photo by shown here. HRTEM is used to check these materials. Yes, interesting thing is we are searching, we are analyzing the old materials, and then we are concluding that nanoparticle was exist. But no written work blockchain or this. There are some examples of vibrant stained glass windows in European cathedrals, and this owed their rich color of nanoparticles of gold chloride and other metal oxides and chlorides. Gold nanoparticles also act as photocatalytic air purifiers. Now we knew this and we are working on this, but still it is very interesting to note, it is very surprising to note they have used gold nanoparticles in 6th century, 8th century, 15th century. So that is very interesting to us. Here I have quoted two interesting examples of discoveries and developments that enabling nanotechnology in the modern era based on increasingly sophisticated scientific understanding and instrumentation as well as experimentation. First was given by Michael Faraday in 1857. He discovered colloidal ruby gold and demonstrated that nanostructured gold under certain light condition produce different colors. So that is the first thing given by Michael Faraday. So you can say even Michael Faraday started this word in the modern sciences. In 1936, Mueller, working at Siemens Research Laboratory, invented field emission microscope. This allowing near atomic resolution image of materials. So these again are something that compel to move to the size at nanoscale. Human mind is very innovative. We want to search too many things. These are the inspirations that we have taken to move to nanoparticles range. Michael Faraday provided the first description of one of the most important property of materials, that is optical properties. He studied optical properties of various materials at nanoscale. He published a very ceremonial paper in 1857, and in that paper he pointed out with the another author Turner, then it is well known that when thin leaves of gold or silver are mounted on glass and heated at about 500 degrees Celsius, then change in properties took place. This change is such that the continuity of metallic film broken, destroyed, and hence the white light is now freely transmitted. Reflection is diminished, while the electrical resistivity is enormously increased. He talked about this, and this shows that Faraday learned a lot about nanoparticles, the conversion of the material in nanoparticles. However, since there were no mathematics or no calculations were developed that time, there were no quantum physics. The discovery were incomplete till Feynman. Advances in interface and colloidal science also helped a lot. Interface and colloid science has existed for nearly a century before they become associated with nanotechnology. If you go in the past, we go in the 20th century, then we can see that the size measurements of nanoparticles have been made during the first decade of 20th century by Richard Adolph Zsigmondy, who also won the Nobel Prize in Chemistry in 1925. He made a detailed study of gold, and other nanomaterials. Size at about 10 nanometer using ultra microscope. And this ultra microscope he developed was capable of visualizing particles much smaller than light wavelength. He also was the first person who first to use this term nanometer, explicitly characterizing particle size. So there are certain examples from the past also. In 1920, the Langmuir, who won the Nobel Prize later on, introduced a concept of monolayer, a layer of material 1 nanomolecule thick, that is called Langmuir-Blodgett films. In the 1950, the Abrikova and Dergaguin conducted the first measurement of surface forces also. So there are certain examples from the 19th century who started the work. We can also remember 1947 transistor Bell Labs. Bardeen, Shockley, and Walter Bratton, they discovered semiconductor and transistors and greatly expanded scientific knowledge of semiconductor interface. This development have given foundation to electronic devices and information age. So we can't forget this that in 1950, Robert Dinger developed the theory and the process of growing monodisperse colloidal materials. And ability to fabricate colloids enables myriad industrial uses such as specialized paper, paints, and thin films. In 1951, Mueller pioneered field iron microscope, as we also discussed in the previous class. This is to image the arrangement of atoms. In 1956, Arthur von Hippon at MIT introduced many concepts of coined the term molecular engineering as applied to dielectric, ferroelectric, and piezoelectrics. So these are the examples that can be deal, that can inspire us to develop new things. In 1974, peoples from Finland developed atomic layer deposition for uniform thin films. They also developed synthesis and properties of semiconductor nanocrystals, and this leads to development of quantum dots in future. Nanotechnology and nanoscience especially got a positive boost in 1980. The reason was development of two major things. The one is scanning tunneling microscope, and the birth of cluster science. How clusters can help in many scientific applications. The development of STM helped a lot to see very small images. These developments led to the discovery of fullerenes in 1985 and the structural assignment of carbon nanotubes in 1991. Many things were developed, but to verify the size, to verify the nano size, there was a need of an instrument. That instrument was scanning tunneling microscope. The development of FinFET in the 1990s also laid the foundation of modern nano electronic semiconductor lab. The interesting thing about this is the nanotechnology took a lead in 1980 in many applications. Gerd Binning and Henrik Rohrer won Nobel Prize for the invention of scanning tunneling microscope. Scanning tunneling microscope gave huge strength to the material science because using this we can develop many things. We can see the image at the edge of nanometer. STM basically an instrument for imaging surface at net atomic level. This was developed in 1981. In 1986, Binning, Kelvin, and Christopher Gerber invented the first atomic force microscope. Yes, within 5 years they have developed anyone that is atomic force. The biggest challenge with the STM is electron beam. You need electron beam. But then they develop AFM. It doesn't need any electron beam. They simply work on force. What force we are applying? After the imaging purpose, initially they have developed for imaging purpose, but in 1989, Don Igler also reported to manipulate atoms using STM. He used xenon atom to spell out IBM logo, and he got shared a very big prize for this one. We can conclude that we have finite evidences that nanotechnology had been used in prehistorical time. We can't say then this is the new subject, but yes, we are researching this in a new way. They have used Roman era have used, or many other sun have used according to their applications for glasses, coloring of glass, for gold and some other things. But systematic studies had not done at that time, even with the era with the Faraday. After the development of quantum physics, we we are discussing this now, and we are merging other subject also as nanobiotechnology. We will discuss the details in the second part of this lecture. The imaging techniques are also helped a lot for nanotechnology and nanobiotechnology. I have given here two questions as an exercise. One is, what is AFM and what is the significance of this AFM for biological samples? As we have discussed in the previous slides, then AFM is very useful. How it is useful than other techniques developed. And there, I'm expecting that cite one example of history from history that I have not discussed here. Many examples can be searched from the websites where they have used various glasses, various techniques, metals like gold, silver, iron, copper. So cite these two. Thank you. This presentation has two parts. I have discussed the first part about prehistory and then the development of nanotechnology. The remaining part with the nanotechnology and nanobiotechnology we have developed as part 2. Thank you.